Hi, my name is Craig Baratella, Automotive Business Development Manager at Emerson for our Branson brand of products and services. I'm going to discuss the use of new polymer materials in electric vehicle development, how these materials relate to plastics joining, and how we at Emerson can help. Developments in electric vehicle design are driving a new set of performance standards for plastic parts used in their production. Newly developed polymers are often required and are having a major impact on how EV parts and assemblies are designed and manufactured. The effect on weld joint designs in particular requires special attention to ensure the overall plastic assembly meets these performance standards. We at Emerson have applications experts ready to work with your project team to develop the weld joint process so it is optimized to meet your specific needs. Let us briefly discuss some of the polymers used in the various EV design applications and their performance requirements. Typically, polymers are grouped in one of three categories: commodity polymers, engineered polymers, or high-performance polymers. These groups range from common, lower-cost, basic performance materials through high-cost, high-performance materials targeted to meet stringent demands. Commodity polymers such as ABS, PP, PMMA, and PE continue to be used in applications such as door panels, front and rear bumpers, plastic tailgates, and center console structures. Camera housings, sensors, battery trays, and pump components are other examples. Redefined performance standards for these applications include lightweighting, compactness of design, impact resistance, and strength. Glass or carbon fiber fillers are often used in the commodity polymers to meet these requirements. The second polymer category, engineered polymers, include PBT, PA6, PA6.10, PC, PPE, and high-impact polystyrene. These polymers are used in applications that make up battery packages, thermal management systems, lighting, and electronics. These applications require a high resistance to impact, corrosion, chemical exposure, and wide temperature swings. High dielectric strength, flame retardancy, strong particulate-free weld joints, and dimensional stability are some others. Glass, metallic, and other fiber fillers are used to meet these design requirements. Material modifiers are also added to these polymers for resistance characteristics mentioned earlier. Blended polymers are also common to achieve combined benefits from each of the compounds. Finally, the third polymer category, high-performance polymers, include PPS, PPA, PVD, and PEEK. These polymers are used for components in power control units, traction motor assemblies, battery cells, and thermal management systems. These components require a V0 rating for flammability, high strength, dimensional stability, low water absorption, and strong particulate-free weld joints, to name a few. Here again, glass or other fiber fillers and modifiers are often added to these already high-performance materials to meet EV design requirements. The material selection and the fillers and modifiers have a significant impact on any weld joints in a component's design. It is essential that material weld feasibility tests are conducted and weld joint design and position within the component be reviewed early in the project to avoid costly designs and timing overruns. It is highly recommended that plastics joining design experts be included on the development team to help optimize the weld joint design and overall component performance. We at Emerson have the plastics joining experts, testing facilities, and technologies to help you achieve success. Emerson's array of plastic joining technologies include ultrasonic, vibration, hot plate, spin welding, and heat staking, along with infrared, clean vibration, simultaneous and trace laser welding, and pulse staking. Emerson also has application labs and testing equipment to conduct weld feasibilities and to develop prototype fixturing and part weld trials. Our experts use these tools to match specific application requirements with the right technology and equipment. Emerson then designs, manufactures, and supplies the plastic joining equipment and tooling to meet your needs. To conclude, electric vehicle development is challenging its supply chain to provide plastic parts and assemblies that meet very stringent performance standards. This requires not only careful polymer selection, but also careful consideration of any weld joints within a specific design. Emerson has the facilities, technologies, and plastics joining experts who are ready to work with your team to help you achieve success. Thank you for your time. We at Emerson look forward to serving your needs.